Computation of diffusion. So, what do you mean by diffusion? We are trying to find out how any phenomena spreads in all directions, starting from one or more target locations. So, we are in a way determining the neighborhood of one or more target locations. That not only depends on the distance between the two, but also on the direction and most importantly the differences in the terrain in different directions. Now, why are we thinking about the difference in terrain? Because these differences in terrains will provide some kind of resistance in the spread of that phenomenon. So we have a target location which might contain some source material, and that source material is going to spread over time in all directions based on the kind of resistance that is provided by the terrain characteristics. So this is called as diffusion, and the source material may be something like anything, like it might be air pollution, water pollution, soil pollution. It may be how the water is flowing in all directions from a spring, water spring, or how the radio waves are traveling in all directions. So we can expect these things to spread in all directions, but it is not necessary that they spread evenly in all directions. So there will be some local terrain factors that will influence how these source materials are spreading, whether it is easier for it to spread or it is difficult. It all depends on the terrain characteristics. So for the diffusion, first of all, we are going to have something called as the source location. So our target location right now is the source location because it is the source of the material which is going to spread. Then what we are going to find out is what is the resistance which is offered by the environment for this which will resist the spread of this source material. So as it is passing by each cell, some kind of resistance will be provided by that cell. So the value which is mentioned in each cell provides an indication of how difficult it is for the source material to pass by that cell. The value must be normalized, which means what? Like whatever the cell is signifying, whether it is 1 square meter or 1 square kilometer or 100 square meters, whatever value is it identifying, how difficult is it for that source material to pass by that region of one cell. So that is identified, and this value is put in each cell according to the resistance provided in that particular area. So a local resistance raster is made, and the GIS will be able to compute a new raster which indicates what is the minimal total resistance has the spread of this source material encountered or witnessed while reaching another destination raster cell. So going from the source to the destination, how much is the minimal resistance it has witnessed while spreading through that cell, through those cells. Now whenever the resistance is computed, we should take care of the lengths of the paths between the two cells. Now if you look in the figure, if this is the source cell and we call it, say, if this is our source cell, then and if we call it as CSRC, C stands for the cell and SRC stands for the source, then if we want to travel to the east and we reach at this cell, then we find that the distance, we just consider that distance as 1. But if you travel in the northeast direction and reach this cell which is diagonally opposite, so the distance is not considered as 1, it is √2. So the distance towards the east cell is 1 and towards the northeast cell is √2. So what is the total resistance which is incurred for the diffusion by moving in these two different directions? So if we move from our source cell CSRC to CE, that means the cell to the east, we get the resistance value as val of CSRC plus val of CE and divided by 2. So half of val of CSRC plus val of CE. Now if you move in the diagonal direction, that means from the source to the diagonally opposite cell, that is this cell, then the resistance will be half of val of CSRC plus val of CNE into, can you see this, √2. Why is that so? Because the distance is not considered as 1 in the diagonally opposite cells, but it is considered as √2. So you can see that the resistance is calculated by taking the value at each cell, adding them and dividing it by 2, and also multiplying it by the distance between the two cells. And hence in case of CSRC to CE, we have half of val CSRC plus val of CE, whereas from CSRC to CNE, that means the northeast cell, we have half of val CSRC plus val of CNE multiplied by the distance, that is √2. Now this is about going from one cell to the other. Same way the diffusion will follow certain path based on the minimum resistance that is provided until it reaches the destination cell. So the total resistance which the diffusion encounters along a path is the sum of the resistances which it incurs during its course of travel from the different cells. So since the source material has the habit of taking the easiest route to spread, it will use the minimum cost path. That means what is a minimum cost path? That path at which it encounters minimal resistance. It does not encounter too much of resistance, then it will choose that path out of all the different options that it has. Okay, and then it will choose that path so as to reach to the destination. So now we are interested in finding what is the minimum cost path. That means we want to find out what is the minimal total resistance along a path from any source location called CSRC to any arbitrary cell. We might call that arbitrary cell as CX. So we are going to go from CSRC and we are going to try to reach at CX. So we will try to find all the possible paths from CSRC to CX and then determine which path has the lowest total resistance. Now let us suppose we want to go from this particular cell to this cell. Now there are different ways of going. Either you go to the north first and then to the east, or you go to the east and then go to the north, or you directly go northeast. So you can see that there are three paths of reaching to this cell. Now we need to find out which is the best path. So what is the best path? That path which is providing the minimal resistance. So let's try to compute the resistance following each path. So let's take the first path in which we are trying to go to the north and then to the east. So when you go to the north, you're going from 4 to 4. So the resistance will be half of 4 plus 4, and that will be multiplied by the distance. The distance between these two cells is 1 because these are adjacent cells and they are not diagonally opposite. So the distance is considered as 1. Same way, if you consider from this cell to the east cell coming in the east of it, okay, it will be, instead of 4 plus 4, it will be 4 plus 5. Okay, so when you add half of 4 plus 4 plus half of 4 plus 5, it is going to give you 8.5, like this. Now let's take the second path, which is from the current cell to the east and then to the north. So going from the current cell to the east, we are encountering two paths, which is 4 and 2. So what will it be? It will be half of 4 plus 2. Then going to the north, we will have half of 2 plus 5, and we add these two. So what we get is half of 4 plus 5 plus half of half of 4 plus 2 plus half of 2 plus 5. Now if you do it, so if you want to go from one cell to another, say we are trying to go from 4 to 2, then the cost is half of 4 plus 2. And if you want to go from this cell to the north cell in the north, then we will have to do plus half of 2 plus 5. So what does that come to? Half of 6, that is 3, and half of 7, that is 3.5. So that comes to 3 plus 3.5, that is 6.5. So this is our answer for going to the east first and then the north. Similarly, we can find out what is the cost of going directly to the northeast cell. So for going from the current cell to the cell in the northeast, what is the total cost? It is half of 4 plus 5. That's it. because we are just going to one other cell. But you know that the distance is not counted as 1, it is counted as root 2 because it is a diagonally opposite cell. So when we do that, we get the value as 6.36. This is because when we take half of 4 plus 5, it is half of 9, which is 4.5, which is then multiplied by root 2. Root 2 is somewhere around 1.4142, and that is going to be multiplied by 4.5, so that gives 6.3639, something like that. So we just considered it as 3.36. Now when we compare these three paths, one which is going from the current cell to the north and then to the east, this is the first path. Second path was going from the current cell to the east and then to the north, and the third path was directly going to the northeast. Now when we consider the weights of or the resistance which is provided by these three paths, we come to know that the first path has a resistance of 8.5, the second path has a resistance of 6.5, and the third path has a resistance of 6.36. So the third path, which is going directly diagonally, is providing the least resistance. So this is the minimal cost path, and this is the path which one should take from this current cell to the next cell in this example of ours. Similarly, we go from each cell to the other cell, which is providing every other cell which is providing the minimal cost.